Welcome everyone to this replay of the talk that we have done at Identiverse 2023 in Las Vegas. So if you are joining this specific recording, it's because you are interested in two things. You are interested into privacy-related regulations at my request that in order to access consumer data, personal information, consent is acquired and checked regularly. And the other part will be about authorization logic and how you can centralize it and make it more fine-grained when you want to protect the data within your application. So the talk of today will be to show you how those two specific items are in fact the two faces of the same coin. And if you do one good strategy, you might tackle both of them in one single shot. So the agenda for the today talk will be the following. We will start with the state of authorization. We will talk about how this specific space has evolved through time. Then we will talk about what are the problems with acquiring consent and only acquiring consent when we try to respond to the control that the privacy regulation can ask out of us. We will see how we can make consent, in fact, a first-class authorization policy into a system. And Jeremy will give you a demo of that to see how you can insert it into your authorization strategy and what will be the user experience related to that. And finally, we will give you key elements for you to be able to grow and implement what we are giving you as an Amazon Verify permission and CDAR policy language strategy into any authorization logic that you have. So it will be a 45 minutes drive. We hope better than a gravel road ride in Alaska, which is a place that we like, Jeremy and I, along this specific schema. So my name is Jeff Lombardo. I'm a senior identity specialist located in Montreal. I joined AWS in September 2020, and I've been specialized into identity for almost 17 years now.
And hi, everybody. My name is Jeremy Ware. I'm also an identity specialist here on the AWS team with Jeff Lombardo. I've got a long history in security, and we're going to be walking through the identity portion today. So let's jump straight into the state of authorization. We're going to do a quick history lesson to make sure that we're all up to speed so that when we start looking at the existing problems that we face today as it comes to authorization and privacy, we can start addressing the solution that Jeff and I have proposed. So quick reminder, what we're talking about here is principles, right? And their entitlements, who has access to what. When we look at principles for the sake of this discussion today, we're going to be focused specifically on user principles. However, a principle could obviously be anything that's making a call to perform an action on a resource. So that could be machine to machine, that could be a user or a consumer. So what we're talking about today is principles that are defined in your accounts that are assigned attributes today, right? So identification equals the definition of who that principle is. The principle is then going to be listed a level of authentication or assigned a series of authentication methods. Traditionally, this has been through credentials. So you might have like a username and password. There may be MFA involved, or you may have some type of FIDO2 key that you are leveraging for passkey authentication. Once they have authenticated against your system, then the user has already been assigned on the back end a series of permissions through entitlements. And so the authorization is checking whether that principal who's making the call, who has authenticated, is actually authorized to perform the action on the resource in question. So let's kind of walk through traditional standards, right? So identity and security standards that we have today are really themselves built on a foundational set of standards. For example, using HTTP enhanced by TLS encryption communication, using strong cryptographic methods in order to secure transmissions that are done. over the open internet. And then we've really branched out from there. So we have our predicated standards, right? What came first. And then we've augmented this with things like AWS SIG v4a signing, MTLS, mutual TLS verification. We've then started looking at things like SAML authentication and several other identity standards like OAuth and OIDC enhancements. But where did we start? So once a user authenticated, how did we start assigning permissions? Well, traditionally, we looked at something called role-based access control, or RBAC for short. And what role-based access control essentially is we've defined a series of roles, and these roles have been given a series of permissions, and then each role can be assigned to the principal in question. Now, this worked great traditionally, right? We might start with an admin role and a developer role and an auditor role. But in the effort of getting more fine-grained access control, the problem that we start to face is that as we want to get finer and finer access control restrictions or follow the method of least privilege, we start creating more roles. And so what started out as a single role for a principal becomes a multitude of roles. And we start getting into this type of role explosion. And all of a sudden, we have several roles that are attached to each principal in question. And it just becomes really hard to manage. And the overhead becomes at scale more than we can handle. So what was the solution? Well, the market came along and said that we have another mechanism called ABAC, or attribute-based access control. Or if we want to add dynamic fine-grained permissions, we can add attributes to a principal that are then tagged to the principal, tagged to the resource, or matched to the tag on the resource, so that we can start matching left to right, principal to resource, who has access to what. If the color tag, for example, on the resource matches the color tag on the principal in this example, then great, they now have access. But what happens as we start to get more and more and more resources is we start to get attribute explosion, just like we had with role-based explosion. And so to combat this, we've hit this problem of, well, which one do we use, or how do we use both together? How do they augment one another, right? And the problem traditionally with ABAC is now it's not just the identity provider that needs to understand the role that can be transferred over to the application, but every time we add new attributes and we want those to augment permissions, the application has to be aware of those attributes. And so all of a sudden, we have this explosion again of attributes on both sides, and management becomes very difficult to handle in the application. So let's look at the good and bad, right? RBAC, role-based access. Great prepackaged group of entitlements. It's given us the ability traditionally, when we start looking at things like workforce management, a really good set of standards to handle permissions, something that we can scale to a degree, but doesn't necessarily hit the fine-grained access control that ABAC allows us to do. And then ABAC, dynamic access control. It's based on contextual information. It's easy to change an attribute and immediately change the permissions. But the difficulty there is, just like with RBAC, we start to hit attribute-based explosion, and the attributes have to carry over from the identity provider that affect the principal, or brought over in the JWT or the SAML assertion, JWT or SAML assertion, to the application. And then the application has to be aware of every single attribute and what that means on the application side. So how do we express both? How do we get the best of both without the overhead and the pain points that both have individually? Introducing policy-based access control. Policy-based access control is really just a unified mechanism to enable you to write policies that are used for authorization that can encompass both role-based access control and attribute-based access control. Think of this as an enhancement to ABAC, much like OADC was an enhancement to OAuth. So with policy-based access control, we get the ability to scale quicker and easier, and we get the ability to leverage fine-grained access control through conditions, which would incorporate attribute-based access control. And these are dynamic, so it does not require authentication code to change. We're no longer dependent on authentication code in order to be refactored or updated anytime we want to make a permission change. And better yet, We are not required to do an audit of code because with policy-based access control, we are abstracting authorization logic from code, which means that they're no longer dependent on one another. All right. Now, how does policy-based access control fall into the zero trust strategy? And what is really pushing the zero trust strategy today? Well, some customers have the ability to invest in security and have a core desire to be as secure as absolutely possible. Others are trying to meet compliance standards or regulatory standards. We have NIST that's come out with new frameworks, the SP 800-207, in order to start giving direction on what zero trust looks like for governance. We have the M2209, right? We have the DoD Zero Trust Strategy and Roadmap that was published in 2022 that is pushing private and public sectors to start looking at a zero trust architecture in order to better secure their infrastructure. Okay, so we're sold on the idea we want to use policy-based access control. Excellent. Unfortunately, there's multiple ways to attack this problem. We could look at a centralized distribution model where all policies are in a single policy store and all is authorized calls are made against the single store. This is great for governance. It's great for accuracy because it's all in one place. But then you implement certain latency that may be there because now your microservices or other services have to reach out to the central policy store. Well, then we could start looking at decentralized, right? We're using a main objective is really looking at local enforcement, and we want to reduce latency. But accuracy could be a problem because now we have to transcribe changes that have been made from the centralized store to a decentralized store. Think of it very similar to domain controllers that are updating, right? There's a propagation or an eventual consistency model there. And then there's distributed, which is really looking at definitions and the ability to be dynamic. And when distributed, we may use a combination thereof. And so there is no one size fits all. As you can see in the graph, these are all equally valuable because of what they're attempting to accomplish. And what really comes down to it is what your use case is. And I want to make clear that the use case doesn't dictate that I will only use centralized or only decentralized or distributed. You really have to assess your use case because you may use a combination thereof depending on the workloads that are in question. Okay, so now we've picked our architectural pattern and we've decided that we want to use PBAC. Dang it, one more decision. PBAC is not a single standard today. There are several policy methods that are leveraged. So let's start looking at some of the goals. We want mandatory access control. We want to be able to leverage role-based access control and attribute-based access control. So we've decided that policy-based access control is the mechanism. But which policy mechanism are we using today, or which policy language, right? We could start looking at Zanzibar, NGAC, Alpha, XACML, CEDAR, Rego. There are several policy attempts at being a standard. And depending on what your use case is and what your team's background are may dictate which standard you go with. Today, we're going to talk about CEDAR.
Okay, thanks, Jeremy. So now that we know a little bit more how our authorization landscape evolve, we know that at the same time there has been a big push for the privacy regulation and how we can protect the data and what we should do to protect especially the personal information. So as we can see, those privacy regulations have evolved through time. Everything started with GDPR in Europe and evolved into some more local privacy regulation in the US due to the fragmentation of the legislation into the country. But overall, it's more and more privacy regulations that are coming up. We saw the LGPD in Brazil. We got the same type of law coming in Canada now. We saw it in Russia, in China, in Australia, and there are many more coming along the way. So we need to consider this as the new normal when we want to protect our most sensitive information, which are the personal information. And if we can just summarize all those controls into one line, what we will see here is that it sounds a lot like implementing a least privilege model in order to control the access to the information. We have to ensure that only principal with justified access can effectively have access to a specific set of data, which are the personal information. So we already start to sense that the way that we have to manage those privacy regulation is very close to the way that we have to handle the access control. But the problem of the guidance that most customers find onto the way they should approach the privacy regulation is mostly around consent collection and data processing impact assessment. This is everything which is visible today. Unfortunately, the thing that is existing into the ecosystem, if we want to really be closer to what those privacy regulation are expecting, is around additional controls that we should be able to look into. Like, do we keep this data into our system? Who has access to what? Who did access to what? Who did consent to the access for this information? How can I prove that someone consented with a high assurance? Because that would be the proof that the regulator will ask from customer organization on how they manage access to the personal information. So in order to tackle those questions, we need to take a look at what is the difference in between having a consent and having a policy-based access control like Jeremy just described before. So let's deep dive into that. So if we compare a consent and a policy, we see that both are required if we look at privacy regulation in order to access to the data. That's okay. We see that consent is scope, but we know that an authorization policy is scope. You don't have access to everything. You are entitled to only specific data element. We see that consent is time bound, meaning that it has a start and an end, while for policies, it can be more complicated, but it at least follow the life cycle of the person who has been entitled to access to the information. We see that consent has a grantor and a grantee, while a policy has mostly a grantee. We often lose the ability to know who give access to what into the system. But does that mean that both of them are irreconcilable? Let's take a look at how we are doing it so far. So we are proposing new way of thinking about consent and to merge it with the concept of authorization policy in order, like we said, to have one strategy to tackle both sides of the equation. So let's take a look at how we can do it. So we said a policy has a grantee and a scope. This is acquired. And in order for consent to be represented as a policy, we know that we need to add two things, the grantor and the time boundaries. So let's see if we can implement that into the system. That sounds something difficult, something that we didn't do before, but that's not true. When we were talking about OAuth2 and GWT's token, like Jeremy said, as a way to handle the authentication, this is already something that we have performed. This delegation of authorization already bear the mark of the grantor through the sub claim, the grantee through the client ID or the audience, the scope through the specific scope claim, the time boundaries with the time the token was issued, the time from which it is effectively active, and the maximum time until which it is effectively active. And it has even an higher level abstraction to it, which is the assurance and the integrity through the digital signature. So we can surely apply that to the way that we are defining our policy. So let's take a look here at the CEDAR policies that we have into our ecosystem. We can find the first information, which is the grantee here, which is the principles that we have to access to the information. We can have information about the scope, which action can be performed against which resources, may also additional information to restrict the scope. We can set specific condition onto the time boundaries, like the not before and the not after condition, and we can add metadata to the system to represent the grantor, but also the integrity assurance if we want to check that this policy document is effectively into the same content that was effectively decided by the grantor at the time that it was set up. So now we know that we can represent a consent in the form of an authorization policy to serve both part of the equation again, the part that the regulator will ask from a customer organization to prove that we are giving access to personal information aligned with the privacy regulation requirement, and also fitting the next generation of access control logic that Jeremy was presenting to us.
All right, so let's look at how we actually do this in reality, right? So Jeff just described high level of exactly how this could be done, very similar to something we've already done in the past. What we're going to show you today is a demonstration of this in practice. So first off and foremost, we want to make sure that if anybody wants to do this on their own in their own environment, they have the ability to do so. So the application that we're going to use today is a CLI application called Tiny To Do. This is available on the OpenSuiter GitHub page for download. This is a separate branch specifically for Timebox. So please go ahead and jump there if you'd like. In order to perform this on your own. What we're going to walk through is actually 4 steps. So first, we're going to go through the basic authorization pattern, which is default deny, right? I want to validate that nobody has access to anything. We'll start walking through a traditional role-based access privilege model. We'll then start looking at direct shares for individuals based on attributes, and then we'll put it all together and show how consent can be made a part of the authorization decision by adding consent as a part of the ABAC strategy in the final policy. We are going to have 4 different personas today that represent different roles within this example application. We have 2 administrators, Amina and Andrew. Andrew is a temp employee. We also have Kesha, who is a temp employee, and Aaron, who is an intern at the application. All right, so let's go ahead and jump straight into the demonstration. So let's go ahead and start our application, Tiny To Do. I'm going to make sure that we're logging our impact here, just to make sure that we can track everything. We're going to go ahead and start the Tiny To Do. We're going to start the server. Before we get started, what I'm actually going to do in another terminal is copy the policies 0 file to represent our CEDAR policies referenced by this application. Let's go over that policy store. As you can see in policies.0, there's actually 0 policies defined here. Now that's really important to note because the first objective we have today is to express that with the lack of policies, the default impact for authorization is a deny, like you would hopefully expect. So let's go ahead and set our user to Andrew, which was our first administrator. We are now user Andrew. And we want to go ahead and create a list called secret sauce, super special secret list. Oh no, but as you can see, we've been denied access. Because even though Andrew is listed as an administrator, there's no policy that explicitly states Andrew has access to create or manipulate any type of list like secret sauce. So he has been denied. So let's go ahead and actually change our policies. What we're going to leverage is policy store.1, and this has a couple of policies in it here. So to begin with, any user can create a list and see what lists they own. So what we've defined here is a permit policy, which means we've allowed some type of statement. And this allows any principal to take the action of create list and get lists on any resource in the application Tiny To Do. The second policy statement here is that a user can perform any action on a list that they own. So we have a permit of any principal, any action on any resource with the condition via the when statement that a resource has an owner and that resource.owner is the principal attempting to take these actions. And then the final policy statement is that a user can list can see a list if they are either a reader or an editor. So we're going to do one more permit policy that says any principal can take the action get list on any resource under the condition that the principal is either in the resource.readers group or the principal is a resource.editors group. So let's go ahead and execute that policy store, update the application. And now let's go ahead and jump back to our app and see if our user or our administrator has access to create the list secret sauce. So Andrew is going to try and create the list secret sauce, and we've been given an authorized. So we've created list ID 0. Now let's go ahead and augment this list. We want to add some things to it. So we're going to create some tasks. We're going to toggle some tasks and choose whether they should be allowed or not. And so we've gone ahead and we've executed that. Oh. We've gotten back an allowed statement as well in our isAuthrized call. And so let's go ahead and try a get list to see what we have here. We have a list of our points of the problem. Looks like this actually executed twice. We have a couple of check marks and our list is ready to go. Now that's fantastic. But what if we want to jump to the other administrator, Amina? So we've now set ourselves as the Amina persona, and we want to go ahead and get list of ID 0, which is the one that was just created by Andrew. We have been denied. Now, why have we been denied? The reason is because Amina has not been given explicit access to this list. She is not the owner of this list, and she has not been granted the attribute or the group assignment to be the reader or the editor of this list. So while she's an admin, she still does not have access because we don't have an applicable policy that would explicitly grant Amina access. So let's go ahead and jump back, and we want to jump back and update our policy store to policy store 2. What does policy store 2 do? Well, some policy store 2, we have added 2 additional policies. For starters, we've added an RBAC policy, or a role-based access policy, that states that admins can perform any action on any resource. So if the principal is an admin, they can take any action on any resource within Tiny To Do. The second policy that we've added to the list is that a user can update a list and its tasks if they're an editor. So if the principal is an editor of the explicit resource, they can take the actions of update list, create task, update task, and delete task. So let's see now if Amina has access, as she should, being an admin to the list. So we still have user Amina, and we'll make sure that we are operating as that persona. So we are Amina, and we're going to try and get that list one more time. Now we would expect, because of the updated policies, that we do have access. And as you can see by the output in the CLI, we have been able to list that list or get that list. Now let's go ahead and check something else. Let's check the user Aaron. Aaron is not listed as an admin. If you recall from the diagram previously, Aaron is actually just an intern. So while Aaron does not have the admin role, the expected output, if he tries to get the list, is a deny. And as you can see here, Aaron has been denied. He does not have the role admin, and as such, there's not an applicable policy that grants him access. Now, Andrew is the owner of the list. So let's go ahead and jump back to Andrew, and let's test something here. What if we want to grant read-only access by adding Aaron to the read list of this resource? So we have our ID of 0 for the list that was created by Andrew. We've assigned Aaron specific permissions, and it is read-only permissions. Perfect. So we have a successful execution where Aaron has been added as a reader to the list of ID 0. And now if we go back to Aaron, what we would expect to see based on Aaron now having this attribute is that when he goes to get the list, he should have access to see. Perfect. And we do have access to see that list. Now, what if Aaron wants to manipulate the list? We want to go ahead and create a task called distribute the slides. Aaron is not an editor. He does not have the attribute of resource.editor. He is only allowed resource.reader, and as such cannot manipulate the list while he can still get the list for view. So let's go ahead and jump to Kesha. Kesha is our final temporary persona, and Kesha is not been granted the reader or editor of the resource attribute, and Kesha is not an administrator. She is just a temporary employee. So when she tries to get the list, as expected, she has still been denied access because we do not have an applicable policy that would grant her access to view, edit, or manage the list in question that is owned by Andrew. So let's jump back to Andrew one more time. We've set ourselves as Andrew, and we're going to go ahead and do the final iteration of our demonstration here, where we are going to grant access to Kesha in a time-bound scenario of 30 seconds to list 0. And so list ID 0 has been shared with Kesha as a reader. So if we go ahead and we jump back as Kesha and we want to view this list and we go to get list 0, what we would expect to see here now that she's been granted as a resource.reader via ABAC in the policy is that she has the ability to view the list. Perfect. And as we expect, she does have access to view the list. Now, without making any change to the policy itself that explicitly granted an allow to Kesha as a reader of the list, we also added the time-bound feature representing consent, which meant that Kesha was only granted read-only access as a part of that policy for the 30-second duration. Now, if you recall the demonstration that Jeff provided earlier, when we were looking at the example, we have a policy that is augmented not only with role-based access control and attribute-based access control, but we've set the allow under the condition that the time is not before or after the specific consent window. So now if Kesha were to go ahead and try and execute a get list outside of that consent window, we are access denied. In this example, what you're seeing is while Kesha has explicitly been granted access as a resource.reader, the consent time boundary has expired and Kesha is no longer granted access to actually read the list. Excellent. So in our demonstration, you were able to see that we created an RBAC policy, an ABAC policy, and a consent-aligned ABAC policy that was augmented in order to enforce consent in a time-bound window to be a part of the authorization decision. So let's look at a tale of two shares. So we did have the ability to share specifically with an individual by creating an ABAC policy, where the principal was able to do the get list action on any resource when the principal was either a resource.reader or a .editor. And this is how we granted access to the two temporary employees, Kesha and Aaron, in order to read the list that was owned and created by the administrator, Andrew. The second set that we were able to do to enforce consent as a part of that time boundary was sharing with the individual, but we also made sure that the resource time box readers was being applied. So the time box range could not start before the current time, and there was a set time limit, which was 30 seconds. And so at the end of that time range, now plus that 30 seconds, that consent would expire. Now, Timebox is an entity in this case, so it's very important to note that this is not a .time window that is operating with respect to something that needs to sync within your application. Timebox is an entity of its own, so we are doing a comparative of the entity time and that range for consent, as well as the RBAC, the role-based access, or in this case, attribute-based access to be a resource reader or editor.
Thanks, Jeremy. That was a great demo. And what I like really about it is that we demonstrated one specific implementation of how those time boundary can be done, but it's just a mental model so far. So you can implement it the way that you are. The second element that I really like about it is that this specific authorization policy remain into the system. So if you want to query the system afterwards to know who had access at some point in time, you can still do that without having those authorization policy being active and leaving access to person who are in fact they should no longer have access to the information. So let's look at what are the key elements that you should take out of this specific mental model for you to drive the next authorization strategy for your customers. So the first point that I want to reiterate is that when you are thinking about the new maturity level for your authorization is to think along PARC. Principle, action, resource, and condition are the four elements around which you should shape your authorization policy. That's great because that can allow human to review it easily, but that's not the only aspect that we are aiming by thinking park. What we like a lot is for system to be able to review it and to enforce it. We know that because at AWS, we are celebrating the 12 years anniversary of AWS Identity and Access Management, which under more than 1 billion calls per second. And that's really the point that matter. By thinking park, we are capable of applying things like automated reasoning to the evaluation, which is exactly what we have put inside our own managed policy decision point that is capable of evaluating policies written in the CEDAR language, which we presented today, and that allow us to reach this specific performance indicator for the number of policy. The second element that I want to have you in mind, that you have in mind when you are thinking about your authorization strategy, is that policies can be of three layers. We can have application owner policy. So let's say that I'm a line of business and I want to create an application. I should be able to say what is possible within my application. And now we define that at integration. And because I have one language that system can review, I can integrate a specific artifact into my application for the different security gate into my CI/CD pipeline to review that. What is important is that because explicit deny has take over any explicit allow, and because the system is is denied by default, I can have security policies. So you already know that into AWS with like guardrail, like service control policy. We can implement the same into the ecosystem if we use a language that can allow that. So at deployment, security into the DevSecOps initiative can apply what is the highest level capability of the system to ensure that no one can define a policy that will allow to breach with what the security expect as the higher gate. And finally, having a standard which is very flexible and which is centralized, like Jeremy said into the introduction, allow definition of policy at runtime, which are more end user focused and that allow end user to decide while using the application what they want to do or not. Like for example, the application, the line of business operator can say within the application, you can share a photo album with someone else. That's great, and it will allow you to do that. But with whom I should share that, as a user of the application, we will be able to define that at runtime. If I want to share it with Jeremy for the next 30 days, for example. So the third point that I want you to get also out of into your strategy will be the fact that you have to bake scope and time boundaries into your policy. Because that's the way that we are thinking about when we want to consume API with the OAuth2 GWT token and the format, the JSON Web Token format that they support. And then we can map element of the API request and element with the token directly with the element of the authorization policy. Like for example, the sub can be matched to the principal. The type of scope can be matched to the way that we are representing scope inside the policy. The path and the method can be mapped to the action and the type of resources that we are going to. And the time of the day, like into a epoch format, can be matched to the time boundaries that we set up into our policy. Finally, it will allow you to unblock new capabilities. The first one is that if you start to reviewing and governance of those different entitlements, you can represent them as graph, which is far more easier for people to look at and to query in order to make some complex request on who has or who had access to what into the ecosystem. The next point is because you keep a record of all those authorizations that you have created into your ecosystem, you can now start to generate proof of consent, and you can follow specific consent receipt specification like the one that has been established by the Kantara initiative. So we provided CIDR as an open source solution in May of 2023. With this come a lot of things. You can use our own playground. You don't need to open an AWS account in order to start to play, define a schema, define policy, and evaluate requests to see how your policy and schema are holding against that. We are providing to you with a CIDR SDK that you are free to use, documentation, examples. Even we are even providing to you the proof that the automated reasoning and the differential testing that was used to secure the CIDR language and all the proof and the research papers that back those engagements that we are providing to you. So now it's your turn to play. For that, you have multiple ways of doing that. We are providing some blog posts that can allow you to write your first CIDR-based application for authorization policy. If you want to use our own AWS service for that, which is Amazon Verified Permission, you will be able to do so. We have 2 specific blog posts that can give you more details onto that. And finally, you can try to join our AWS Community Builder program that can allow you to make a big difference on how those different solutions can evolve and how they can be used into the ecosystem. So thank you for watching this broadcast. For sure, if you want more information, don't hesitate to reach out to me or Jeremy, and it will be our pleasure to follow up with you along those conversations.
Thank you.